Find the particular angles of sine, cos and tan of the following angles. 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now consider an equilateral triangle. An equilateral triangle means that all the angles are the same and all the sides are the same, but we have to make the sides 2 units. So drawing a diagram, ABC, ABC, so each of these sides are going to be 2 units. If it's equilateral, that angle will be 90 degrees, and if we drop down the perpendicular, so that's the midpoint there, we call that N, then that angle there will be 30 degrees. Remember, all the sides are 2, and therefore if this is the midpoint, that will be 1 and that will be 1. Right, by Pythagoras' theorem we can actually calculate this length here by doing the square root of 2 squared minus 1 squared. So that's going to give me root 3. So this length here is root 3. So I want to consider this angle here, which is 30 degrees. It's 30 because it's half of 60. And then if we label this as a right angle triangle, consider this triangle here, then this will be the opposite to that angle. This will be adjacent to that angle, and this will be hypotenuse to that angle. So sine of 30, sine is opposite over hypotenuse, so it's going to be 1 over 2. Cos of 30 is cos is adjacent over hypotenuse, so it's going to be root 3 divided by 2. And then tan of 30 degrees is going to be 1 over root 3, opposite over adjacent, but from our rules of surds, then we know we can write that as root 3 over 3. Now what we're going to do is consider this angle, which is 60, so that means that this is now the opposite, because it's opposite to 60, and this side will be the adjacent next to the 60, and the hypotenuse will be the same. So sine of 60 is opposite over hypotenuse, so it's going to be root 3 over 2, very similar to this one over here. And then cos of 60 will be adjacent, which is 1 over the hypotenuse, which is 2, and then tan of 30 will be opposite over adjacent, which is root 3 over 1, which we'll just write as root 3. Right, now what we're going to do is consider a right-angled isosceles triangle with equal sides 1 unit. So this is an isosceles triangle. This angle here will be 90 degrees, which will mean that these two here will be 45 each. This length is 1 and this length is 1, and then by Pythagoras we can calculate this length here. So by Pythagoras, EF will be the square root of 1 squared plus 1 squared, which is the square root of 2. Consider this angle, although we could consider this one as well, but if we consider this angle, then this side is the opposite, this side is the adjacent, and this side is the hypotenuse. Sine of 45, well, sine is opposite over hypotenuse, so it's 1 over root 2. Sorry, this length is root 2. So it's 1 over root 2, which from our rules of surds we can write root 2 over 2. Cos of 45, well, cos is adjacent over hypotenuse, again that's going to be 1 over root 2. Again we can use our rules of surds, which is root 2 over 2. And then the tan of 45 will be 1 divided by 1, opposite over adjacent, which is 1. So we've now established particular angles for 30, 60 and 45. What about 0 and 90 degrees? Well, at 0 and 90 degrees you don't really have a triangle, but if we look at this applet, so here we have a right angle triangle. This is the angle at the moment. This is the adjacent, this is the opposite, and this is the hypotenuse side. Now, if we make the angle near to 0, I can do that by reducing the size of the opposite side. Okay, so we'll do that, we'll bring it right down to here. Now what happens to, you need to look what happens to sine and what happens to cos. Right, the opposite side would come very, very close to 0. So what happens is that the sine becomes very, very close to 0. So we can say that the sine of 0 is actually 0, but the cos becomes 1, and that's because the adjacent and the opposite side are almost coinciding. You can see that from this diagram here. Okay, if we actually make it 0, then we can see what happens. Okay, because this distance is now 1, the opposite doesn't exist, and this length still has a length of 5, then this will be 0 over 5, which is 0. So sine is 0, sine of 0 is 0, cos of 0 is 1, and tan of 0 is 0. Now what happens if we make the angle 90 degrees? So let's just take the opposite side back to that, and now reduce the side of the opposite side. Okay, so what we're doing is we're now making the adjacent side very close to 0, and now you can see the opposite is going to happen. The sine of 90 is approaching 1, 0.99 is 1, and the cos of 90 is approaching 0. The tan is just getting bigger, but if we now make that even smaller, okay, what we get is this sine becomes virtually 1 because the opposite and the hypotenuse of the triangle are going to coincide, and the cos is going to be even smaller, going to be 0, and tan is even larger. But if we actually make the side, we're going to have 1, the opposite, the adjacent side is 0, so get 0 over 10, and then the tangent, what we're going to have is the opposite side is 10, but we're dividing by 0, which we can't do, so that's going to be infinite. Okay, so when a sine of 90 is 1, cos of 90 is 0, and tan of 90 is infinity. So, and this applet I will attach to this video. So if we go back to this, we can now make a table, and then this table needs to be learned. So put sine, cos, tan, degrees 0, 30 degrees, 45, 60 and 90. Now there's another way of measuring angles which we call radians, which we'll look at later, but these need to be remembered. 0 is 0, 30 is called pi by 6, 45 is pi by 4, 60 is pi by 3 and 90 is pi by 2, but don't worry about these at this stage, we'll look at these now. If we started with 30, we know the sine of 30 is a half, the cos of 30 is root 3 over 2, and the tan of 30 is 1 over root 3, or root 3 over 3. Now the next one to fill in is this, is 60. What you do is you take this one and put it down here. It's a way of remembering it. This one is root 3 over 2, and then this one will become 1/2, and this you just take the reciprocal of this. So it would be root 3 over 1, which we just write as root 3. Now for 45 they're all the same, 1 over root 2 over 2, 1 over root 2 over 2, and the tan of 45 is 1. And then from 0 degrees we've got the sine of 0 is 0, cos of 0 is 1, tan of 0 is 0. And then for the sine of 90 is 1, if we use the applet to get these, the cos of 90 is 0, and the tan of 90 is infinity, it doesn't exist. Okay, so these are the particular angles. Now you will need to learn these if you're doing any sort of advanced A-level or IB mathematics. This table needs to be learnt. Okay, so this has been a video to show you how to deduce the particular angles and then come up with a table. And just repeat, the table needs to be learnt, and the GeoGebra applet is attached to the notes of this video. I hope you've understood, and I thank you very much for watching.